皆さん、こんにちは。Hello, everyone. Thank you for joining us today. I would like to talk about how ANA built a single source of truth with Snowflake and Apache Iceberg. First, let me introduce myself. My name is Takashi Ioka, and I work in the DX department at ANA, a Japanese airline. I have led the creation and promotion of a customer information sharing platform aimed at enhancing customer experience, advance our digital marketing capabilities, and encourage data utilization frontline operations. Currently, I am promoting data management initiative across the entire ANA group. Here is our agenda for today. We plan to cover 3 main topics, followed by a closing. I will be talking about the first 2 topics and the final closing, but BlueLake in action will be presented by Yotaro Matsuura. First, let's talk about ANA. ANA Group has 3 airline brands. First, there's ANA. It is Japan's leading full-service airline. Based on our results from 2024, ANA carries the most passengers in Japan for both domestic and international flights. Second is Peach. Peach is Japan's largest low-cost airline, and it mainly flies within Japan and to other countries in Asia. Third is Air Japan. It just started flying in February 2024. Air Japan is a hybrid airline. This means it mixes the good things about both low-cost airlines and full-service airline. It offers low ticket prices and mostly fly medium-distance international routes. Today, ANA Group does more than just an airline business. In recent years, we have been trying to connect with our customers not just when they travel, but more in their daily lives. To make this happen, we are working on making this so-called ANA economic sphere, where customers can live using their miles. This is a new challenge for us, but it will enable customers to enjoy our different services more easily. Okay, let's look at ANA Group in numbers. As of December 2024, ANA Group has 56 companies and about 41,000 employees. To give you a rough idea of our staff, we have about 4,000 pilots, 8,000 cabin attendants, 4,000 maintenance staff, and 12,000 airport staff. Our group's total sales were about $15.6 billion for fiscal year 2024. We serve about 48 million passengers each year. We also manage a fleet of 278 aircraft, including Airbus A380, which is the world's largest passenger airplane. Also, Skytrax, a UK rating agency, has recognized ANA as a 5-star airline for 12 years in a row since 2013. As a 5-star airline, ANA is very grateful to its customers. We will not get comfortable with our past rating, but will continue to offer safe and high-quality air travel filled with dreams and excitement to customers around the world. To mark ANA's 17th anniversary, all our employees discussed what we want to be in the future, and we renewed our management vision. Our vision is uniting the world in wonder. This phrase shows a strong hope. We want all our group employees around the world to actively take on new challenges. We also want them to offer new value by staying close to our customers and society. And we hope to fill the world with excitement and happiness. NA Group is speeding up investment in areas where we expect growth, and we aim to make as much profit as possible. Also, by working closely together within the group, we will use data to create new value and plan to further expand our NA economic sphere. NA has a wide network of routes to major cities around the world, such as North America, Europe, and Asia. We fly you safely and comfortably to your destination on our newest airplanes. We offer 4 classes: first class, business class, premium economy class, and economy class. So you can choose based on your needs and budget. Whichever class you choose, we welcome you with special service to help you enjoy your flight. In Japan, we highly value seasonal flavors, so you can choose from the variety of high-quality Japanese and Western dishes that we offer. We believe our brand, Inspiration of Japan, comes from 3 customer experiences: sparkling, caring, and Japan quality. Inspiration of Japan is the special NA experience we want our customers to feel through these 3 experiences. Safety always comes first for us. Building on that, we want to give our customers exciting and enjoyable travel experiences. We do this by combining Japan's modern technology and skills, its bright and exact ways, and the warm, caring service that ANA has always valued. This unique experience that only a Japanese airline like ANA can offer is the brand we always want to give. We believe data is very important for customers to experience our Inspiration of Japan brand. We look at all the times customers interact with ANA: before their trip, at the airport, on the plane, and after their trip. We have defined these as 28 key scenes in ANA customer experience, and we use data to see how well we are doing in each scene. Using data that we manage centrally, we provide the same information through our digital channels and also our staff, like cabin attendants, airport staff, and contact center staff. We are always working to improve the customer experience. Also, we are making data easy for all our employees to access and use. This is sometimes called data democratization. This way, we can use the skills and ideas of all our employees to help us improve even faster. For our second topic, we will discuss our data management project. There are 3 things we believe are important in our efforts to democratize data. The first is the mechanism or the environment in which data is handled. The second is human resources, or the people who handle data. And the third is governance, or the rule for handling data. All 3 elements are essential, but today I would like to focus on evolution of data infrastructure, where the mechanism and environment for using data is important. We have set up 2 main data systems. The first is our CX platform, which handles real-time information to help us serve our customers. The second is BlueLake, which is often called a data lake or data warehouse or data lakehouse. BlueLake helps us get useful insights from data analysis. These two systems work closely together, and we are actively using them to improve the customer experience, help our employees be more productive, and make better business decisions. BlueLake is our data analysis platform, which we showed you on the right slide of the previous slide. We use Snowflake as the main technology for this system. We are using BlueLake, our one platform, in all parts of airline business, covering everything from marketing to operations. This helps us encourage the use of data across different departments. Thirdly, and this is the main part of our presentation today, we will share our concrete activities. In this session, we will look into BlueLake through architecture and challenges. All right now, Matsuura-san, a member of my team, will speak to you. Hey, Matsuura-san, let's switch.
Thank you, Ioka-san. Hello, everyone. My name is Yotaro Matsuura, and I'm a data architect at ANA. I began my career with ANA in 2020 as a new graduate and joined the data team in 2021. My initial responsibility involved the development of our data catalog from scratch. In 2022, I played a key role in the BlueLake development, eventually becoming the project owner. I designed the architecture, led the project, and drove the adoption of Snowflake for BlueLake. And now, since April, I'm exploring new strategies for leveraging our customer data. So let's move on to architecture of BlueLake. This is our current architecture. As you can see in the center, this is BlueLake. I will now dive into the details of why we designed this particular architecture. To begin, I want to share the core concept of BlueLake. In the past, NA relied on separate, siloed, traditional data platforms, each designed for individual airline business unit. However, these silos prevented us from connecting and utilizing data across those units, which limited our capability to achieve our growth strategies for NA Group. That includes our non-air businesses. As a result, we had to rebuild an integrated data platform that could support all NA Group's operations. We launched BlueLake as a common data platform for NA Group with a plan to gradually integrate existing systems and add new features. Our key decision was to physically centralize and unify data management to enforce a single source of truth. Let's discuss why we chose a strategy of physically centralized data in one place. The core issue was the inability to connect and analyze data from disparate source systems. We faced inconsistencies such as differences in data timestamps, the number of digits used for member IDs, and name stories such as a single field or split into multiple fields. From a data management perspective, it's best to handle the data at its origin, but modifying data structure in many such solutions is often impractical. Therefore, in BlueLake, we developed data unification procedures which enable us to combine data across systems and business domains. This included standardization tasks such as aligning the length of flight numbers, standardizing data types, and name storage and member ID lengths to allow for linking of pseudonymized data. Starting with its first release in 2022, BlueLake evolved through 3 generations. and we are now working on its fourth generation this year. I'd like to take you through the architectural changes in BlueLake from its early stages to the present. In the first BlueLake, called V1, we cared most about two things: strong protection of personal information and flexible data utilization. Previous data warehouses had some problems with insufficient ways to protect private data, especially concerning compliance with evolving data privacy regulations. And we could only get the data out using Excel. BlueLake V1 tackled these issues by using pseudonymization and separating accounts. With security as our primary concern, we implemented a complete separation between personal information and non-personal information areas at the account level. We brought all data into personal information area and then generated a non-personal information area by pseudonymization, hashing all data. This made it possible to conduct cross-functional analysis that identifies individuals even in the non-personal information area. We evolved the capability for users to freely issue SQL in a secure non-personal information environment. Moving on to BlueLake V2. Following the same basic idea as V1, we decided to use Snowflake as our database. The old database we used in V1 had some issues. Whenever a project added data or jobs, the performance got bad. So we had to design and check the size of the nodes, and every single time we had to develop ways to add nodes and do performance tests. Snowflake's architecture, with its complete separation of compute and storage, allows for the creation of multiple independent warehouses. This resolves resources conflicts between projects, ensuring secure and reliable data access and utilization. Furthermore, Snowflake's seamless connectivity with the third solution allows for rapid integration with Spark and Tableau, delivering analytics platform to a wide range of users. Snowflake adoption provided numerous advantages, and in terms of database operations, we realized cost saving in three key aspects. Database usage costs were cut by more than 50% compared to projected expenses with our former solution. Database development work was drastically reduced with an estimated improvement of almost 80%. Regarding operations, as operational workload was significantly lessened, we consider 90% improvements were made. Now, let's talk about BlueLake V3, our current operational version. We enhanced V2 environment with improved personal information management and data standardization capabilities. This enables us to streamline personal information deletion and audit operations to ensure compliance with evolving personal data regulation across various nations. To address this trade-off, deleted personal information is excluded from digital marketing and customer support activities. However, we implemented measures to maintain data integrity and prevent any statistical discrepancies in the non-personal information environment. This is why physically separated the environments with personal information and non-personal information. These slides show the overall architecture of BlueLake V3. The data pipeline has also been enhanced since V2. Our primary approach is to process data in S3 and serve it by referencing it as external tables from Snowflake. For larger datasets, we also ingest them into Snowflake as internal tables. Although BlueLake has evolved over the past 3 years since 2022, we maintain a consistent philosophy to manage data effectively in files, the most flexible format. Back in 2021, when we were planning BlueLake, we recognized that managing data even with files would allow us to fully leverage constantly advancing technologies. While Snowflake is our primary tool now, we acknowledge the potential for even better solutions to appear in the coming years. Moreover, we are simplifying data management by establishing a file-based single source of truth. With files as our data management foundation, we are seamlessly integrating Snowflake for data warehouse alongside AI, BI, catalogs, and processing engines. And in 2025, we are currently in the process of evolving to BlueLake v4. For upcoming BlueLake v4, we are moving towards a full adoption of Iceberg, an open table format that exhibits excellent compatibility with our architectural design. We are now in the validation stage, and I'd like to share our progress. The architecture of V3, which relied heavily on external tables, presented challenges driven by the dramatic surge in data volume and the expanding number of files stored in BlueLake. Some data processing was also being carried out in internal tables, resulting in inconsistencies with our initial aim of a single source of truth. The repetitive loading of data from S3 into the database was inefficient, and disaster recovery became difficult. Performance was also a concern, as scanning the massive volume of parquet file on S3 was slow, and we were also constrained by the inability to fully utilize Snowflake's performance acceleration capabilities such as micro-partitioning. As a result, we were keen to adopt Apache Iceberg, which we believe could effectively address this issue. Here is the architectural concept based on Iceberg. Aligned with the single source of truth principle. When data is stored using Iceberg, metadata is managed in Iceberg catalog, and the data itself resides in storage S3. Firstly, this significantly improves data storage efficiency. In the V3 architecture, data had to be stored in S3 and then defined as an external table in Snowflake. However, in V4, saving data as Iceberg within Snowflake automatically deploys the data to S3. Secondly, data access is also made more efficient. Snowflake, as well as other solutions utilizing Spark, can also reference Iceberg through a common catalog. When working with Iceberg tables, the selection of metadata management catalog is required. Given that many Iceberg catalogs are still in their early stages, it's very challenging to decide which is best at this point. Nevertheless, we are currently considering leveraging Snowflake Managed for Iceberg. The reason is that it offers storage in the open table format of Iceberg, while maintaining a consistent interface and performance comparable to Snowflake internal tables. We undertook a POC to assess the capability of Snowflake Managed Iceberg by conducting a performance comparison between our V3 and V4 architectures. Given that V3 utilized both external and internal tables method, we evaluated each of these against V4's Iceberg approach, focusing on two critical areas, ETL and query performance. The ETL process covers the complete workflow, including standardizing raw data, applying pseudonymization, and finally publishing it to our data warehouses. For querying, we simply execute select statement against each table. For this performance validation, we leveraged real production data across 6 distinct tables. These tables represented a wide range of sizes from a massive 10 billion row table with over 10 million daily updates, down to smaller tables of around 1 million rows. We performed 10 test runs of these tables, leveraging appropriately sized warehouses. Now, on the right side of the slide, you can see how an iceberg table is created. Once connected to external storage, you simply execute a create iceberg command, much like a create table command. And now, for the exciting part, the result of our POC. First, for ETL processing, the result indicates that V4 iceberg tables achieve 3.9 times faster performance than V3. Second, for query execution, the result indicates that V4 iceberg tables achieved 1.6 times faster query performance than V3. In summary, as presented here, we've identified significant advantages for V4 leveraging Iceberg. While these figures showcase the table with the most substantial performance gains, even for tables showing more modest improvements, we still observe the speed up of approximately 1.6 times for ETL and 1.1 times for queries. Based on this result, we are now starting full development for V4. This slide shows the overall architecture of BlueLake V4. With Iceberg, we are moving away from direct data processing across S3. Going forward, data processing will be performed between Iceberg tables directly within Snowflake, and the data will automatically be stored on S3. Our approach for V4 involves two key areas: data transformation and enhanced ETL functionalities. On the data front, we are converting our existing parquet files into the Iceberg format. For ETL, we are integrating dbt for Iceberg processing through Snowflake, complementing our current use of Glue for parquet files. This effort will enable us to be more adaptable to change and operate with increased agility. Let's now turn to the topic of challenges. I'm going to share 3 laser challenging scenarios involving Snowflake. The first challenge is a POC exploring the collaboration between generative AI and our data platform. We developed a prototype application leveraging Streamlit and LLM functions to recommend travel destinations to customers. Even if you receive a highly abstract request from your boss, like, is there anything we can do with data and generative AI? It's easily achievable within Snowflake. I built this application through a process of trial and error as I was new to Streamlit. The structure is illustrated on the right, and we successfully implemented both the logic and the LLM in a single program, fewer than 200 lines of code. The fact that data processing, Streamlit, and the LLM are all handled within the Snowflake environment makes development highly efficient. This is the actual screen. You specify your preferred travel style and date, and it recommends destinations after verifying data, including flight availability. To illustrate, if a tourist visiting Japan seeks recommendations for travel destinations where they can immerse themselves in Japanese culture, here are 3 recommended destinations. Kyoto is an ideal place to experience Japan's historical background with numerous cultural World Heritage sites. Hiroshima offers numerous tourist attractions, including the stunning shrine on the sea, as you see in the photo. Tokyo provides a glimpse into modern Japanese culture. Beyond this travel information, the application can also suggest optimal flights for your journey. While the accuracy is still not perfect, preventing it from being a live service at present. Our hope is to use this prototype to inspire other business divisions and eventually bring it to practical application in the future. The second challenge is a POC for Snowflake Custom Data Connector. The work of integrating data into the data platform is, in my opinion, a very laborious and time-consuming endeavor. In an attempt to improve efficiency, even slightly, we explored the use of a custom data connector. We succeeded in building it in fewer than 3 days at a cost of only $10 per month, and it ensures secure connectivity with zero inbound connections. Moreover, it's easy to manage. If the data source meets the requirements, we think it could be a good fit for production deployment. Here is the content of our POC. We built an end-to-end data pipeline from ingestion to prediction using Snowflake and dbt. We developed data ingestion pipelines using Snowflake Notebooks, allowing daily retrieval from SNS APIs like X via external access integrations. Raw data is loaded into Snowflake tables, then processed with dbt-SQL. Lastly, by implementing Snowflake Cortex ML as a dbt custom materialization, the entire pipeline is SQL-driven. The third challenge is the internal development of data tools. While we also leverage such data utilization tools in light of NA Group's 40,000-strong workforce, we developed in-house tools essential for data democratization, a data catalog and data extraction tool. The data catalog has been able for 4 years and extraction tool for 1 year, and both are seeing a continuous increase in users. By developing these tools internally, we'll be able to achieve significant cost saving in terms of running expenses. The data catalog tool is built to be accessible even to users without deep data expertise, and we've implemented various features to foster daily usage among all data consumers. For example, the daily data refresh status is displayed prominently on the main page, and there are displayed preferences that can be adjusted based on user skill level. Additionally, it includes an LLM chatbot leveraging metadata as RAG and a commenting functionality akin to social network sites. The data extraction tool is designed to allow even those unfamiliar with SQL to extract data using a drag-and-drop GUI interface. It integrates with the data catalog, displaying data field names with logical names and providing accompanying data descriptions. As we primarily utilize Google Workspace, it offers seamless export of query data directly to Google Sheets. Furthermore, it incorporates query sharing functionality and schedule record execution. I've shared 3 examples of our challenges so far. These data challenges were successfully addressed by building BlueLake with Snowflake. By unifying our data platform, optimizing cost, and enhancing development efficiency, we feel empowered to utilize data with significantly increased agility compared to before. I would like to conclude one presentation here and pass the mic back to Ioka-san.
Thank you, Matsuura-san. Hello again, I'm Ioka. Now to offer some closing remarks for this presentation. For us, digital transformation is simply a means to an end. Our main vision is that our DX enhances the customer experience for ANA users, improves employee workflow efficiency, and creates value in a way that balances corporate sustainability with our ESG commitments. However, because technology is advancing so rapidly, we feel it's extremely important that our architecture design is based on a clear philosophy. With the evolution of generative AI and the practical application of various other technologies, NA Group will continue to leverage the strengths of its people and strives to maintain a cutting-edge data infrastructure as core value. We will continue to take on new challenges with all our might, aiming to create a world filled with excitement. NA Group will continue to soar forward with strength. When you come to Japan, please try flying with ANA. We look forward to seeing you on board. Unfortunately, in my limited English, I would like to accept any questions after this session. Please feel free to contact us individually. Thank you very much for your attention.